Guys, you can see this is our Sim800L module. This over here is a USB to TTL device, and circuit is as shown in the presentation. Now guys, this is a Putty terminal I am using to send messages. You can see that I had used this command called AT plus CMGS to send the message on this number, and this number I have in my mobile phone. The first message I sent was this: learning microcontroller Sim800L module tutorial, and then the second message I sent was this: learning microcontroller YouTube channel. And the third message I sent is the LM tutorial on Sim800L interface USB to TTL device. So this I am sending through the computer using that Sim800L module. So let me show you what we are receiving on the phone. And if I go to the phone, see here, you can see all the three messages are received. Now see, some messages are distorted. See here, we wrote something else, but we received something else. It's not a problem because we are using a Putty terminal. This is because of the serial terminal. You can try other terminals as well. So guys, simple as that. Hello guys, welcome to learning microcontrollers. In this video I'm going to show you how you can connect a Sim800L module with a USB to TTL device to send SMS using a PC or a laptop. So what we are going to do here is that we will wire up the Sim800L. So I will let you get started with a Sim800L, and then we are going to connect the Sim800L with our computer, and from there we will send the AT commands, and then we will send an SMS to our mobile phone. So let's get started. So guys, this over here is the Sim800L module. I had just blanked this because this part, that is the IMEI number and other stuff, you should not look at it. It's someone's private property. So right now this is fine till now. Okay, just I have blanked it for this. There will be some information here like IMEI and other numbers. So guys, this is our Sim800L module I am talking about. It is the top view, this is the bottom view, and here you can see that it has mentioned the pin configuration as well, that it says the net pin on the top. So here you will connect the antenna, VCC, RST, RXT, TXT and ground, and on the left side we have more pins. So here, now don't get confused with a lot of pins, like we can see many pins, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pins. But don't worry, we will not use them. To get started with the Sim800L, you only need 4 pins. Now that's a great news. So let me show you what you need, not what you don't need. So for this, to send an SMS to your mobile phone using a Sim800L module, you need a VCC pin here. Then you will need the RST pin, the reset. This is not necessary, but if your module gets stuck, instead of turning off the supply, you just like touch it to the ground for 100 millisecond, it will reset the module. So it is not of very much use. Then you will use the RXT pin, TX pin and the ground pin. Now these 4 pins, ground, TX, RX and VCC, these are the 4 pins we are going to need. Reset is also not necessary. Now guys, here you know that if we see the TX and RX pin in a module, it means that it is a UART protocol supported. So this module requires a UART protocol to operate. So when in our next videos we are going to use a microcontroller like PIC16F777A or an Arduino for it. So we will make sure that whatever controller we use have a UART port, because this module needs it. Now guys, this is our micro sim. Remember, the module I have supports a micro sim. So if you have a nano, then you have to use a jacket. If you have a bigger sim, then you have to cut it. So I prefer you use a jacket if you have a nano, because mostly nowadays we use nano. So this will support a micro sim, and you have to insert it in this way, face down. Just turn its face down and then you insert it from the back. Now guys, this over here is our CH340 USB to TTL device. You can use any available USB to TTL device found in the market like CP2012 or something like that, or an FT232, or if there is any other USB to TTL device, you can use it. Remember, whatever the USB to TTL device you buy in the market, there are always 3 pins, TX, RX and ground. They are in every UART to TTL device. Now guys, let me label this for you. It's a CH340 or FT232. They all have same pin configuration. Let me show you what these 6 pins mean. And here we have our Sim800L module. So as you can see, that CH340 USB to TTL device, the top pin is a 5 volt, VCC, 3.3 volt, TX, RX and ground. We are only concerned with the TX, RX and ground pins. In some other versions of this module, like if you go with a CP2012 or any other USB to TTL device, these 3 pins may differ. 5 volt, VCC, 3.3, some have 3.3, some don't have 3.3. TX, RX and ground are everywhere. So this is normal. Now guys, the next thing is we have our Sim800L module. Now the next thing is the wiring of the SIM800L module as shown in the previous slide. We only need VCC, reset, RX, TX and ground, and out of these 5 pins we only need the VCC, RX, TX and ground pins. Rest of the pins you do not need to connect, and at this net pin you will connect an antenna if you have an antenna, and on the other side there is an IPEX header as well. You can use that to connect an IPEX antenna. Usually it comes connected, so don't worry. Now guys, this over here is our power source. Now remember that SIM800L module is a power sensitive type of module. If you give it too much power, it sometimes don't work correctly. Sometimes it will send a distorted message or bad message. That is because of the power. Your power must be between 3.7 to 4.4 volt, and this is a good thing. You know that these voltages from 3.7 to 4.4 are not used in many things, but if you go into the depth, every battery that you find in the market, like 1865 cell or any sort of cell you find in the market, 3.7 volt cell is easily available. Your mobile battery is 3.7 volt. The rechargeable cells easily available in the market are 3.7 volt. So this is great to have this. So you can directly connect a battery, and remember that you do not connect your SIM800L module directly with a CH340 USB to TTL device or an FT232 or with a PIC16F877A or with an Arduino or any microcontroller, because the problem is this draws a lot of current when in full mode. So you need a supply which can support a current up to 2 ampere. In my case, I'm going to use a DC power source. You can use a battery as well. Battery directly supports 3.7 volt voltage, so that will be more than enough. So remember that, don't like connect it here, I show you how to connect it. Now your power source will have 2 terminals, positive and negative, like every battery have a positive and a negative wire. Now let's do the connection. Connect the positive of your battery or a DC power source with the VCC like this. Now that's how you're going to connect it. And for this CH340 USB to TTL device, do not connect any power source to this, because it will go into the computer and computer will power up this device. So you do not need to connect any power source here, just you need to common the ground. So let me show you how to common the ground. Now you common the ground of SIM800L module with the CH340 USB to TTL device like this. Now you common this ground with the battery or the DC power source, whatever you have. So ground of all 3 devices, the CH340, the SIM800L and your battery or DC power supply will be common like this. Now guys, we have the TX and RX pin. Now usually what happens is that TX goes to RX and RX goes to TX. Now there comes another problem, that SIM800L operates at 3.3 volt usually. It operates at 3.3 volt logic. Now for that you either need a module to send commands to the SIM800L module. So TX of your CH340 will send the data to the RX of your SIM800L module like usual. But if you directly connect it with an Arduino or with a PIC16F877A, they operate at 5 volt logic. So SIM800L may get burned. So to overcome this problem, either you use a microcontroller which supports 3.3 volt logic like ARM, Cortex, M3, STM32, Nord MCU. They all work at 3.3 volt logic. So with that you can directly connect RX to TX. But here in this case you cannot do this. So what you do is that instead of using a logic module that is a big module and takes a lot of wiring, we just use 2 resistors to go for the voltage divider. Now a voltage divider made using a 10 kilo ohm resistor and 20 kilo ohm resistor can give you 3.3 volt, because 10K resistor is available everywhere and also the 20K. So you can use this. You can make the 3.3 volt using any other configuration using 2 resistors as well. So that will also do. Now guys, like this, first this is a 10 kilo ohm resistor and this is a 20 kilo ohm resistor. What I do is that I connect the one end of the 20 kilo ohm resistor to the ground with a common ground like this, and from the other end of now for the 10 kilo ohm resistor I connect its one end to the RX pin like this. Now the other end of the 10 kilo ohm resistor and the 20 kilo ohm resistor I common them like this. Now from the same point I will connect it to the TX of the CH340 device. So in this way you get a voltage divider which will make sure that the TX data coming from the CH340 device is stepped down or voltage divided into 3.3 volt for your SIM800L. So this is a very easy way to do it, because this resistor is very cheap. Both resistors may cost you like very little in pennies. So this is a great solution. Now guys, for the TX pin of the SIM800L, since now it's a SIM800L which will send the data to the computer through the USB to TTL device. So our Arduino PIC and this CH340 device have no problem in receiving a 3.3 volt logic. So directly connect the TX of the Sim800L to the RX of your USB to TTL device. In this way our circuit is completed. You can go without a voltage divider as well. It may work, but there is a heavy possibility that your module may get burned. Now in this way our connections are completed. Now let me introduce you to the hardware before we go to our. So guys, this over here is the hardware, as you can see, and you can see that this is my Sim800L module, and I told you that I removed this because it had the IMEI number, so I didn't want it to share it. Now see, it's a Sim800L module. It came with this antenna. I didn't pay for it, but it came free with it. So that's why I didn't need to solder an antenna on this pin. See that my net pin, this pin over here is empty because I got the IPAX antenna. So this gets installed here. So once you if you have the IPAX antenna, you do not need to solder a spring or anything here. So this is an edge of having this antenna. If you don't get the IPAX antenna, then you have this antenna with it. You just solder it at this point over here like this. You just place it here and solder it at the net pin. Now guys, this is our Sim800L module. Now this over here, you can see that I am using a DC power source to power it up, and for the CH340 it will be the computer which will power it up. Now guys, what I do is that I turn on the power supply for the Sim800L. Now see, Sim800L is powered up. You can see that it is getting powered from the DC power source, and the voltage on the DC power source I have set it to 4.2 volts. See, it's 4.2 volt. Now guys, now the voltage is set and our Sim800L is powered up. Now what we do is that we connect the CH340 USB to TTL device with the computer. Now the CH340 USB to TTL device is connected with the computer. Sim800L is blinking the LED. So everything seems fine. See, it is blinking. Now we go to the, now just go to your browser. In the browser, we need a serial terminal, and I recommend you use the Putty. Write down Putty, download. It's a free open source serial terminal, very powerful. This, the first link, putty.org, click on it. It's free, so don't worry. And click on this, download Putty. And here you have these links. And go for the first one, that is Putty 64-bit. I click on it, it will download it. Okay, it's downloaded. I already have it installed. I was just showing you how to do it. Now just click on it and install it. Click on next. In my case, it is installed already, so I will just repair it because I have it installed. I'm just trying to show you. Now Putty is installed. Now once it's installed, go to the search bar, type Putty like this, and here you have the Putty. Click on it. So this window pops up. Now this is the Putty serial terminal. Now in the session window, click on serial. Now the COM port, first of all, go back, go to your device manager, just go there in the PC. Here you just right click, go to the properties. On Windows 10, you have to go to the device manager, whichever window you have, and in the device manager, go to the COM and ports. Now what I do is that I can see two ports, 1 and 11. I don't know which port belongs to the serial communication device. Now I remove the device. Now device is removed. I go back. I check which port is gone. Now see, the port number 11 is gone. So this means I connect the device again. Now, okay, the COM has so it is USB serial port is COM 11. Now I am dead sure. So go back to the Putty. Here you write the port COM 11 because 11 is the COM. Okay, let me zoom in further so you guys can see better. Now guys, in this way our Putty is initialized. The COM port is selected. Now and the baud rate doesn't matter. You can set any baud rate, it will auto detect the baud rate. 9600 is ideal, it's normal baud rate by default. Now guys, on the Putty the writing will be very small. To make it larger, I am going to change the font size. You may go with the font size that's available. I make it 16 and I make it bold. I click on OK. It's just a font type, so it doesn't matter even if you don't do it. Now click on OK. So guys, this is the Putty terminal opened up. So let me zoom out so you guys can see how it looks like. So this is the terminal which will open up. Okay, now zoom in. Now write type AT and press enter. Okay, so this means the module is returning OK, which is perfect. Again write AT, it returns OK, that's fine. Now I write another command called ATI. So ATI, this will the module should have returned the model number, and it is showing the model number Sim800L or 14.18. So that's perfect. Now guys, I check if my sim is working or not. I write a command called 80 plus COPS question mark. Now see, it reflects Pactel. Now if whatever the network you are on will reflect that. So I am using a Pactel sim. I reside in Pakistan, so it's Pactel network here. So it's working fine. Now let's check the signal strength. What is the signal strength? I write 80 plus CSQ, this command, and it shows 12. So this will be like from 0 to 31. So 12 means it's like less than half. Signals are not very good here because I am sitting at the ground floor and there are 2 floors above me. So that's fine. Now we get to the real stuff. We write a message. Now to write a message, first of all, you have to put your module into something called text mode. To put the module in the text mode, you write this command 80 plus CMGF. This command equals to 1. Now it reflects OK. It means now the module is in the text mode. Now we write our message. To write the message, use this command 80 plus CMGS equals to semicolon, write the number here. First of all, 3 digits plus, then the country code. In my case, it's 92. Now write the number 349. That is what I'm going to write here, 862243. Now see, 2 digits. First will be the plus, the other 2 will be your country code, then these digits, 10 digits will be your number. So in my case, it is 349862243. Now I close the brackets like this and I press enter. Now it gives an error. It gives an error in the first attempt. Now if you can copy this command or just rewrite it, it happens sometimes. CMGS equals to plus 92 349 86 2243. If it's possible, just copy this command, or I might have copied it somewhere, and now press enter. Now it's working. See, I just tried it the third time, copy pasted it, it works. Now see 80 plus CMG, now this arrowhead has appeared. It is right. Now it is waiting for you to write the message. Now what I write learning microcontroller Sim800L tutorial. Okay. And now instead of typing enter, if you type the enter key, this will not send the command. This will not be sent. So you have to press Ctrl Z, press Ctrl plus Z. Now this command will be sent. Wait, see, it's sent. Now I open my phone in which I had sent the command. Let me show you the phone. Let's zoom out and see, did we receive the message or not? Okay, I go to the phone. Okay, let me show you the phone here. Okay. Now see, on the phone we received this message here, learning microcontroller Sim800L tutorial. See, now again I try to copy this, again I paste. Okay. Now see, we have received the command. Now I send another message. So let me zoom in. I write something else. Now again copy this command from here, paste it here. Okay, now it's fine. Just right click it to paste it, 80 plus CMGS. It's better that you write this command in a text document and just paste it here, because Putty is not a very powerful terminal. Now I write a message called learning microcontrollers YouTube channel. That's what I wrote here. Now instead of pressing enter, remember, do not press enter key. You cannot press the enter key. You have to press Ctrl Z. Only then this will be sent. If you press the enter key, see what happens. If I press enter, it moves to the next line. This arrow will not go away. Like, to send the message, you have to press Ctrl Z. Now press the Ctrl Z. Now it will send the message. See, it's sent. Again, let's go to the phone. Okay, we received a message here. So let me open it. Okay, here we go. There is a message called, see, learning microcontroller YouTube channel. Now see, there is some distortion as well, so it sometimes happen. Now the above was fine, bottom is a bit distorted, so no issue with that. It's because of the terminal we are using. You can use it, try the different terminals as well, but this is how you get the Sim800L up and running for the first use. So it is very simple. You can send any message you want. So I send another message. Again I zoom in, I paste a command, I press enter. Now it is waiting for the message. I send LM tutorial on Sim800L interface USB to TTL device. Now that's the new message. Now instead of pressing enter, if you press enter, this will happen. Now press Control Z, Control plus Z. Now see, wait, the message is sent. Now let's zoom out and show you we received the new message. Okay, let's check the new message. Okay, what is the message we received? See, the third message is here. LM tutorial on Sim800L interface USB to TTL device. So this is fine, guys. We are getting our messages using the Sim800L modules. So this is how you use this module, guys. I hope you guys learned something from this video. If you guys have any questions, you can ask me in the comment section. In my next videos on Sim800L module, I will show you how to interface this with a PIC16 FA777A microcontroller to make very awesome projects, and with Arduino as well, and other microcontrollers as well. So guys, we'll see you in the next video. Thank you very much for your time and have a nice day.